All right, so we're going to talk about some complex number operations. And what we're going to be doing when we're talking about this, we're only going to focus on addition, subtraction, and multiplication. I'm not going to cover division. So a complex number, is a combination of a real plus an imaginary part. And what this means is we'll usually say this is going to be a real, we'll call that A. Our imaginary, this is going to be B, and we'll have that I as basically to show that this is the imaginary part. So when we're doing this, we've got A plus BI. And this is what all of our complex numbers are going to look like. Now, as you might imagine, if you're adding or subtracting, there is not really a lot that's going to be special with this. If you're adding or subtracting your complex, you're just going to add like a polynomial. So add that like a polynomial. So this is going to be, so if I've got, say, 3 minus 2i, and I'm adding that to, say, 5 plus a 7i, okay. Here, none of my signs are going to change, so this is going to be 3 minus 2i plus my 5 plus my 7i. 3 plus 5 is going to be 8. Negative 2i plus 7i is going to be plus 5i, and we're done. None of it, just like adding or subtracting polynomials, our exponents don't change unless we're multiplying. If I am subtracting, well, we just have to distribute through our negatives, or through our second polynomial. So if I've got something like, say I've got say 2 minus a 6i, and I subtract like 3 minus a 2i. Well, this is going to be 2 minus 6i minus 3, and because we're distributing that negative, plus 2i. So this is going to end up being negative 1 minus 4i, and we're done. So adding or subtracting complex numbers is quite straightforward. We're just going to add these like a polynomial. Where things get interesting is when we start to multiply polynomials. And you're going to hear me make a bad joke here in probably just a few minutes. But if you're multiplying a polynomial, or if you're multiplying a complex, you're just going to multiply like a polynomial. And here's the other steps that you're going to need to do. You're going to need to resolve your power of I. And for most of these, this means, for most of what we're going to deal with, it's just remembering again that, I is I. I squared is negative 1. I cubed would be negative I. And that I to the 4th is 1. And that pattern just repeats. I, negative 1, negative I, 1. So what we were doing in that last video. Most of the time, we're just going to end up using probably just this fact for most of what we're going to do. So let's take two complex numbers. Let's say I've got 3 minus 2i, and I'm going to multiply this by 2 plus I. And we're just going to go ahead and multiply like we would normally any two binomials. So with that, I FOIL. 3 times 2 is going to be 6. It's going to be plus 3i. Negative 2i times 2 is going to be minus 4i. And then negative 2i times I is going to be minus 2i squared. So when I put these two, I'll put my two terms here together. I've got 6 minus I. And then I'm going to resolve my power of I squared into a negative 1. So this is going to be 6 minus I. And I'll have minus 2 times a negative 1. So this is essentially going to be, 6 minus I plus 2, or I'll have 8 minus I. And we're done. And I think you can tell that as you get more adept with this, I showed all of these steps. We could literally have taken all of this and probably gone from here almost straight down to the answer. You could just say, okay, we're just adding these middle two terms to find your imaginary part. You're just gonna say, oh, this I squared means I'm going to flip the sign here. Let's do another one. Let's do another example here. And let's say we've got something like, I'm going to do 5 minus 2i, and let's multiply this by 1 plus 2i. Okay, 5 times 1 is 5. 5 times 2i is going to be, it's plus 10i, then minus 2i. And the negative 2i times 2i is going to be minus 4i squared. So again, we can think about this a little bit. I could say, oh, this is going to be 5 plus 8i. And I'm going to go ahead and just think for a moment and say, okay, 4i squared, this is the same thing as minus 4i squared. That's the same thing as negative 4 times negative 1. So this is going to be a positive 4. So I could just add 4 here to the end. Oh, this is going to be 9 plus 8i. And we're done. Three steps. Now, there is one type of multiplication. It's one of those things that I like to bring up whenever we're multiplying complex numbers. And it's one of those things that is very helpful for us whenever we're thinking about multiplying things. Remember what happens when we multiply together conjugates? So if I have like a plus b times a minus b, well, let's see what happens when I do that with complex conjugates. So if I take any complex number and multiply that by its conjugate, so a plus bi times a minus bi, a times a is going to be a squared. I'd have minus abi. Then I'll have positive bi times a is going to be plus abi. And then bi times negative bi, that's going to be minus bi squared. Well, these two things, because it's a conjugate, my middle two terms cancel out. So I've just got a squared and minus this that's b squared I squared. But that I squared just is a negative 1. So this is going to turn into a squared plus b squared. Notice that there's no imaginary parts of this. And I did promise you the bad joke. Yes, you take an imaginary, or you take a complex number, you multiply it by its conjugate, and shit gets real. Thank you. I'm here all week. So just to show you this, say we've got like 3 minus 2i. I were to multiply this by 3 plus 2i. I could, in fact, just use this shortcut to say, oh, this is going to be 3 squared plus 2 squared. This is going to be 9 plus 4. I'm going to expect this to come out to be 13. So let's show you. That's 3 times 3 is 9. That's going to be plus 6i minus 6i, and then minus 4i squared. Sure enough, we've got 9. Those cancel out. That's going to be minus 4 times negative 1. And, yep, that comes out to be 13. Alrighty. That's what we've got, and we'll see you in our next video.